Okay, so in this video, I will show you how to make the TPMS, that stands for the Tire Pressure Monitoring System, using those very cheap tire pressure sensors from AliExpress and this ESP32 board with this OLED display. And those pressure sensors are meant to be mounted on your wheels, on your tires. You will just screw those on your tires, but since I don't have enough space for a tire here on my bench, I will simulate the pressure with this huge syringe. So this pressure is FL, that stands for the front left. I will put this sensor inside the syringe, cover the top with my thumb and apply some pressure. And hopefully after a few seconds, the value on the OLED display updates, which seems to be the case. We can now see the pressure in PSI as well as the temperature in degrees Celsius. And if I now remove the pressure sensor from the syringe, the pressure will drop. It will measure this normal atmospheric pressure, which according to Wikipedia is around 1 bar or 14.696 psi. And that's actually the value that we see on the OLED display. It shows the 14.6 psi. Just to let you know, the required pressure for cars depends on the used tires, but it's usually between 30 or 40 psi. So let me quickly test all the other sensors to make sure that they also work. So here is the FR, which stands for the front right. Again, I will put this inside the syringe and apply some pressure and wait a while until the value on the OLED display updates. Remove it from the syringe and continue with the next sensor. This one is RL, which stands for the rear left. Again, put it inside the syringe, apply some pressure, wait for the value to update and then put it out. And finally the last sensor, which is RR, which stands for the rear right. And since this one is also reporting the pressure value as well as the temperature value, it seems like that everything is working as expected. So let's get started with our project. Actually, before we start, let me tell you about the sponsor of today's video, which is PCBWay. And that's because if you are making electronic projects, sooner or later you might need PCB or PCB assembly or SMD stencils, and in all those cases, PCBWay has you covered as they offer all of those services for a reasonable price. On top of that, if you use the link down in the description, you can get 10 PCBs for free, only paying for shipping. And if you need anything else than PCBs, you can also get services like 3D printing, CNC machining or injection molding. So thank you PCBWay, and let's get back to our video. So let's talk a little bit about those pressure sensors, because there are many types of TPMS sensors and you want to choose the right ones. They can be either placed inside the tire, which is the case if you have them already installed on your car, or they can be placed outside the tire, which is my case. You will just screw those on the valve stem cap instead of the current cap, and that's how they measure the pressure. And it's actually fine to use both types of sensors. The only difference is that for the internal ones you need some special equipment to put them inside the tire, and that's the main reason for me to use the external sensors instead, because I don't have such tools. The more important detail is how those pressure sensors report the pressure values. Obviously the wheel is rotating as you are driving, so there cannot be any wired connection, so there is always the wireless connection. The OEM pressure sensors usually use radio waves, and those aftermarket usually use Bluetooth. To be exact, they use BLE, which stands for the Bluetooth Low Energy. So if you see the Bluetooth symbol on the package or the word BLE, you are probably fine. Those sensors are powered by batteries. For this particular sensor, you can unscrew the bottom part and the battery could be replaced. But let's go back to the BLE connection. Using a BLE means that those sensors can be connected to your smartphone and you can see those pressure values on your phone. And that's all great, but there is a catch. I wasn't able to do that. I have tried two suggested applications, one called the SYTPMS. But after clicking the pair button, the loading animation was spinning. It was trying to connect to the sensor, but it never did. And as you can see, it eventually failed. And since there is not much else to set inside the settings, I did move to the second application called the TPMS Plus. I have clicked the plus button and selected I have 4 sensors, 4 wheels. And I've pretty much tried all the possible bind options, including this auto bind, and clicking the bind sensor button. But even after searching for a sensor for 1 minute, it didn't found anything. At that point, I wasn't really sure if my sensors are faulty or maybe if those batteries are dead, so to make sure that those sensors really work, I've decided to not use any more TPMS applications and instead switch to a different type of applications, and that would be a simple BLE scanner tools. I did start with the application called the BLE scanner, which scans for the BLE enabled devices, and you can see that there are actually many BLE devices around. Most of them don't have the name, so NA means not available, but there is, for example, this one which is a television, or this one called the LYWS. And the nice thing is that this tool also shows approximate distances of those BLE devices, and while most of them are far away, like this TV is more than 100 meters away, this one, the LYWS, is quite close, it's actually less than a meter away. So I thought to myself, this must be it, this must be my pressure sensor, but after a quick Google search for this name, that's actually not the case. This is the thermometer that I have next to my PC. So there are many devices inside this list, but I don't think that any of them is the pressure sensor. After a quick googling, I did found out that the pressure sensor might not be sending any data if there is no pressure to save the battery life. So I did put the pressure sensor inside the syringe and applied some pressure, and let's wait a while. And there is a new device in the list called the BR, which seems to be very close to my phone. And although BR is the unusual name for a pressure sensor, I think that's the one. So let's go to the application settings and select filter and filter by name, and the name will be of course the BR. And enable the filter, click done and apply the filter. Then I will apply the pressure, and indeed after a while we have that device on the list again. The important thing to notice is this label not connectable, because unlike other Bluetooth or BLE devices, you cannot actually connect to the pressure sensor, which means that you cannot send any data or any messages to that sensor. The sensor is just sending out the pressure data and that's it. And we can view the data if we click the raw data button, which we cannot click right now, because as I was talking, I wasn't applying the pressure to the sensor and the sensor was no longer reporting the data, so I need to apply the pressure again and it should appear again on the list. And now we can click the raw data button, and this is the data that's being transmitted from the pressure sensor. And this is the most important part, because hopefully inside those 8 bytes, somewhere in there is the pressure data, the pressure value. Actually, those are not 8 bytes, it says 8 bytes, but if we count those individual bytes, we only have 7 bytes. What we can do now is to apply some pressure, look at the data, apply a different pressure and look at the data again and see if anything has changed. But with this application, it's a lot of clicking and I only have 2 hands, so I have switched to a different application called the simple BLE scanner. And even when there are not that many options in here, it shows the data being sent, which is this one, it's the manufacturer data. So let's again filter by the name, being the BR, and here it's correctly saying that the length of the data is only 7 bytes and we can immediately see the data being sent. And so you can hopefully see that as I'm changing the pressure inside the syringe, the last 3 or maybe 4 bytes are changing as well. Now just to make sure that other sensors are working as well, I can probably put 2 of those sensors inside the syringe, and if I do so and apply some pressure, I can now see 2 of those devices inside the list. So let's write down the received data and see if we can make any sense of it. So this is the data that I have received, those 1, 2, 3, 4, 5, 6, 7 bytes. And as I was searching, I did found this page, which is some ESP32 BLE scanner. That was a great start. But after that, I did found this GitHub page, which is specifically for BLE TPMS for the tire pressure monitoring system. And here is some manufacturer data being sent, so this is the data, but unfortunately the amount of data being sent on this page is quite different from our data. So here there are 17 or so bytes and we only have 7 bytes. So this is quite different, and I actually think that this might be the reason why the TPMS applications on my phone were not working, because they were expecting this kind of data, but instead they were receiving this data. With that said, it's possible that a different tire pressure sensor might be sending this data, so it's definitely something to keep in mind. Anyway, for me, it was time to move on, and I found this GitHub page, which also has the Bluetooth BLE TPMS sensors, and in this case, it says that the name of the sensor is BR, which is the same as our name, and then there are 7 bytes, which is also aligned with the number of bytes that we are seeing. The first byte, in our case the byte 80, is some kind of status. Let's just ignore this for now. The next byte is 1F, which should be the battery voltage. And if we convert 1F into the decimal, that's 31. And if we divide it by 10, it's 3.1 volts. And since we are using the coin cell battery being the CR1632, where the standard voltage for a fully charged battery is 3 volts, and our battery is most likely fully charged, I think that the 3.1 volts is a reasonable number. The next byte is 1A, and according to this page, it should be the temperature in degrees Celsius, so again converting 1A into the decimal number is 26, and 26 degrees Celsius is actually the temperature that my thermometer is currently showing. Finally, we have the 2 most important bytes, which is the absolute pressure in PSI, and those are those 2 bytes, so in our case that's the 0092. And if we convert the 0092 into decimal, that's 146. And then if we divide it by 10, it's 14 by 6 psi. And if you remember the beginning of the video, that value is most likely the lowest pressure value that this sensor is reporting. Again, that's the normal atmospheric pressure, so at some point I was applying some bigger pressure, but as I have lowered the pressure, the sensor was still updating the data, still sending out the new values, until it went all the way down to the atmospheric pressure being the 14 by 6 psi. So I think that this value could also be a correct value. The last 2 bytes, in my case that 1474, that's some kind of checksum, and I think that we can ignore it for now. Now before moving to the Arduino and ESP32, I want to do one last test of the pressure, that is run the application on my phone, apply some known pressure and look for those 2 bytes. And since I have milliliter markings on my syringe, I think I can use the ChatGPT to calculate the pressure. And let's ask what would be the pressure if I squeeze those 100 milliliters into, for example, 60 milliliters. And the final answer seems to be 24.5 psi. So let's actually try that. I will put the sensor inside the syringe and set the volume to be 100 milliliters, and then try to squeeze it to around 60 milliliters and wait for the application to update to show me the value, and it seems to be 00F1. And if we convert 00F1 from hexadecimal to decimal, that's 241, and divided by 10, that's 24.1, which is pretty close to 24.5. I mean, not exactly 24.5, but we haven't accounted for the volume of the pressure sensor itself, so I think that we are pretty close. And since I'm pretty happy with the result, I think that we can say that this sensor works as expected. Now, if we want to read the BLE data, we need some Arduino compatible board that has the BLE support, which is pretty much most of those ESP32 boards. So today I will go with this board, which is the Seeed XIAO ESP32S3 board, mainly because I have it from my last project, and also because it's small and I have this expansion board with the OLED display. With that said, again, most of the ESP32 boards should work for this project. So let's jump back to the PC and install that ESP32 board. The very first step is opening the documentation, and it looks like that even for this ESP32S3 board there are 3 different versions, but if we scroll down they all support the BLE connection, so we can use any of those. I'm actually using the first one, the most basic one, being the ESP32S3 without any extra words. And then if we keep scrolling, there are a lot of useful informations about all the details of those boards, but I'm looking for the way to install this into the Arduino IDE, which is this chapter, so we need to first download and install the Arduino IDE, which is something that I've already done. This is the Arduino IDE, and then we need to go to the file preferences and select the additional boards manager, which is down there, so additional boards manager URLs. And if there is nothing in here, you can just copy paste this line, But if you already have something in here, you need to click this button and just paste that URL. Click the OK button and OK button. And then we need to select Tools, Board, Boards Manager, or just click this icon which is for Boards Manager and type in ESP32. And we need to install the ESP32 by Espressif Systems. And if you look at the documentation, the version should be at least 2.0.8. Which seems to be the case. I have the 3.2.0 installed, which means that now I can select Tools, Boards and go to ESP32. And somewhere down there should be the XIAO boards. So let's just keep scrolling until we see those XIAO boards. And again, the board that I'm using today is the ESP32S3. And the nice thing is that once we select the board from here, we don't need to care about any other settings because they should be automatically set to the default or the correct values. Which means that the only thing that we need to do is to connect the XIAO board to the PC using the USB-C cable and then select the correct port, which in my case seems to be the port number 11. Now by selecting the ESP32 board, what has also changed are those examples in the file menu, so File, Examples. We have some basic examples up here, but then we have a lot of examples for our particular board. And one of those examples is this folder BLE for the BLE communication. So let's start by opening the scan example, which should be for scanning BLE enabled devices. So let me just maximize this window. And this sketch should be searching for the BLE enabled devices and printing the data into the serial port. So let's try to compile and upload this sketch to our XIAO board by clicking the upload button. And this might take a minute or two. And then once this is uploaded, let's open the serial monitor by clicking this button and make this bottom window bigger. And you can see that it's already finding some devices, at least this device. So again, I will put the pressure sensor inside the syringe and apply some pressure. Then wait a while and it looks like that this might be our pressure sensor based on the data. So we are getting 1, 2, 3, 4, 5, 6, 7 bytes. And it's kind of aligned with the data that we were receiving before. The only problem is that we don't see any name, actually we don't see name for most of those devices. So let's see if we can fix that. I have found this Stack Overflow page where someone is asking the very same question, and there are 3 proposed solutions. Starting with setting the set active scan, which seems to be the case, we are doing that in the setup function, so that should be fine. The other proposed solution is to increasing the set interval and set window time, and we have it currently set to 199. And I've tried to set it to a bigger number like 400, but that didn't make any difference. So the last proposed solution is to change the CPP file from the library. So let me just open that file, and in that file we want to locate this line and copy and paste this line before that line. So let's just paste this one before the line. And let me just add a comment that I've added this based on this Stack Overflow and save it, and then go back into the Arduino IDE, close that serial monitor and then try to upload it one more time. And then after this is uploaded, we will open the serial monitor again, and let me make this smaller. And again, let's apply some pressure to the pressure sensor. And we now see our BR pressure sensor, so that's great, so we can see the name, the address, the manufacturer data, even things like the service UUID and the signal strength. But we really only care about the address because that's how we will differentiate those different sensors, and the manufacturer data because that's where those pressure values and the temperature values are being stored. However, if we look at the source code for this sketch, all this data, this one line is coming from that line. So if we find something, we will just print the advertised device.toString, so we'll convert it to string and then we will convert it to the C string. So pretty much all that we see in here, so the name, address, the manufacturer data and all the other information, this is all being stored in this object. Which means that if we want to access the name and the address and the data separately, we need to somehow get this data from this object. And I think that if I open a different example, a different BLE example, for example this beacon scanner, this might have some clues. So if we look at this code, it has the advertised device.have name. So if the device have a name, we can get the name calling the getName function. And then down here, if it has the manufacturer data, we can get the manufacturer data by calling the getManufacturerData function. And if we keep scrolling down there, the manufacturer data is being printed. So let's use bits and pieces from this code in our code and print all those details if we find a device that has a name BR. So if we find a device which is this line, we are printing all the data. But before we do that, we want to see if there is a name. So if the advertised device has a name, and if the name is BR, and we can get the name calling the getName function. So if the getName of the advertised device, so if the advertised device equals BR, and one thing that we need to change in here, we have the C string, so it's converting the normal string into a C style string for printing this out. But we don't want this for the comparison because we would need to use a special C style comparison string functions. So instead we will just get this, which I guess will get us a normal kind of string, the string with the capital S. And if this equals BR, in that case we will print this data, but let's just change it, found BR device, and let's print out all the data. And just close all those open brackets, so one here and one for this if function. And let's try to upload it to the ESPIAO board one more time. As usual, once this is uploaded, let's open the serial monitor and apply some pressure to the pressure sensor. And it's currently saying that it's finding two devices, but since we are not getting any data and not printing any details, those devices do not have the BR name. So let's wait a while. And usually the first reading takes slightly more time. But you can see that now it found the BR device, again with the address and the manufacturer data and all the error stuff. So again, our sketch is only printing data if it found a device with the name BR. So let's continue with the next step. And that would be printing the manufacturer data. I mean, we are already doing that kind of, but we want to store this inside a new variable and then print it out. So once we find a device with the name BR, we want to see if there is any manufacturer data by calling this haveManufacturerData function. So if it is the case, so just copy and paste that into our code. We want to print that data, and it looks like that we can get the data by calling this getManufacturerData, which will give us the string value. And then it looks like that we are converting this string value into the C style array, so C manufacturer data array. So we can then access individual bytes, so just copy those 3 lines into our code as well. And then there is some iBeacon specific code, but down there we are printing all those individual bytes. So I'll copy these lines of code into our code as well. And here we go over every single byte of the C manufacturer data and print it out using the printf function. By the way, the C manufacturer data array is type of unsigned integer 8 bits, but I think that we can as well write unsigned character or just the byte value, which is the Arduino specific, but it should work in the very same way. That is, this is the array of bytes. One last thing is that I'm missing one of those closing brackets in here for the if manufacturer data, and then we can try to upload it to the ESPIAO board to see what happens. Then again, open the serial monitor and apply some pressure to the pressure sensor. And indeed, after a while, we see the manufacturer data, all those individual bytes. Just a minor detail, I don't like that some of those bytes do not have 2 values, so not having the leading zeros. But I think that inside the sprintf function we can say 02, which means that we will be padding those values with zeros to have at least 2 digits. So let me just quickly re-upload this. And now all those bytes should have 2 digits. So at this point we know the name, although we are not storing it anywhere, and we have the manufacturer data being stored inside this C manufacturer data variable. The one last thing that we are printing but not storing is the address. And if we look at the beacon scanner sketch, there is unfortunately no function for getting the address. However, what I think that we can do is we can look at the BLE advertised device.header file by control clicking on this name, and that will open the header file. And there should be a list of functions that we can use, and one of those is this getAddress function. So let's try to use that address inside our code. So once we print everything, once we print the manufacturer data, which is this section, we can try to print the address, and again we will call it advertised device.getAddress. And just because this is resulting in some BLE address type, let's try to convert it to a string using this toString function. And let's print it out using the serial print line function. And as expected, after uploading this sketch to the XIAO board, we see all the data, then those individual bytes for the manufacturer data, and then the address of the device. So we pretty much have all the data that we need for our next steps, but I think that before moving on, it would make sense to take all those individual sensors and write down the address for each of those. So this one that we have right now is for the FL, that's the front left sensor. And let me actually put this inside the sketch somewhere, so I don't forget. So the FL sensor address is this one. Then wait a while until this sensor stops sending the data and use, for example, this one, the FR, the front right, and apply some pressure. And here we have another address, so this will be for the front right sensor. And continue like this, also with the rear left and the rear right sensors. You might have noticed that on those sensors there is something which looks like the address, like for example this 0A on the front left sensor. But that byte or that data is nowhere to be found inside the address, so I'm not quite sure what this is really for. Anyway, at this point, we know how to get the data that we need, and we have all those 4 addresses of those individual sensors. So I think that what we can do now is to separate those individual bytes into individual variables to store the pressure, temperature, and the battery voltage. So I've added a few more comments to make the code more understandable. Again, we are getting the manufacturer data and storing it inside this string value, the string manufacturer data, and then we are converting it to the C-style array, being this C manufacturer data, which can hold up to 100 bytes, but again, we are only using 7 in our case, but just to make sure that if we ever receive more, we have some space in here. And then let me actually paste an example of what we are receiving together with the explanation of those individual bytes. So we can say that this C manufacturer data with the index of 0 is the first byte, and that's the status which we will ignore for now, so we can move on to the next value, which is the number 1, the index of 1, which is the second byte, and that should be storing the battery voltage. So let's create a new variable, and the battery voltage is a floating point variable. And in the beginning, let's start only with the one sensor, and that could be, for example, the left front. So let's name this variable left front voltage. And the left front voltage will be the second byte from this array. But if we only set it like this, we will get values like 31 or 30, basically 10 times the voltage. So we want to divide it by 10. But in order to do that, we need to first convert this variable, which is a byte variable, into the float variable by casting this to a float variable. And that should give us the correct voltage. Let's continue with the next information, the next byte, and that's this one, that's the temperature in degrees Celsius. And this one is actually the integer value, so let's call this left front temperature. And this one will be actually even easier, because all that we need to do is to get the third byte, which is the byte of the index number 2. And that will get the temperature in degrees Celsius. And just to make sure that our approach works, let's try to print those values using the serial print line function, so serial print line. And we will first print the voltage, and then we will also print the temperature. Let's upload this to the XIAO board and see what happens. And there is some problem. The C manufacturer data wasn't declared in this scope, which kind of makes sense. If only there is a manufacturer data, then we are creating this variable. So I think it will make sense to move our code a little bit and do that assignment only if we have some manufacturer data. So move it in here instead, and then try to upload it to the XIAO board one more time. And when we now apply a pressure to the pressure sensor and open the serial connection, we see 0 and 0 for the voltage and temperature, because we are printing those values all the time, at least for now. But after a few seconds, we see our BR device and those values being 3.1 volts and 26 degrees Celsius. So it looks like our approach is working, so let's move on to the most complicated data, and that's the tire pressure. And the reason why this is the most complicated data is because the value is spread across two different bytes, so this one and that one. So to make it slightly more understandable, I will create two more values. The first value will be of the type unsigned integer with 16 bits. And let's call it left front pressure PSI multiplied by 10. And then create one more variable, and that will be type of float, and that will be the final pressure in PSI. Now this type of variable takes exactly 16 bits or 2 bytes. So if we imagine how this looks like, it will be 1, 2, 3, 4, 5, 6, 7, 8 bits, and then 1, 2, 3, 4, 5, 6, 7, 8 bits. And what we want to do is we want to assign this byte to this half of our variable and the second byte to the second half of our variable. So this byte is 1, 2, 3, 4, so it's index of 3. But if we just simply say that it's the index of 3, what will happen is that this byte will be assigned to the second half. So in order to move those 8 bits, this one byte to that part, we need to offset it to the left side by 8 bits. And we can do that by using this operator, which is the bit shift to the left side by 8 bits. So now this byte, the byte of index of 3, is being stored on the left part of our variable, maybe. And I say maybe because this variable is still type of byte, so 8 bits. So if we bit shift it by 8 bits to the left side, there is no space because there are no additional bits in here. So before moving that, we need to cast this variable to also have 16 bits, so using the very same type of unsigned integer with 16 bits. And now it should be working. So after we do that, we want to also add the second variable, and that will be the byte with the index of 4. So what we are doing is we are using 2 bytes for our 16-bit value. That will be with the PSI value multiplied by 10, and then we can use our second variable, which is type of float, and we can say that this one will be the PSI multiplied by 10 divided by 10. And again, it will be hard to divide this value because this is type of integer, so I just cast it to the float instead. So this will be the pressure in PSI. So let's actually try to print this value together with other values. So using the serial print line function, we will also print the front left pressure PSI. And let's try to upload it to the XIAO board one more time. So in the beginning, we see all 3 values being set to 0 because we are not getting any value yet. But hopefully after applying the pressure and waiting for a while, we will see some values, and that seems to be the case, so 3.1 volts, 27 degrees Celsius and 22.3 psi. So let me try to just not apply any pressure to go all the way down to the atmospheric pressure, and it's going down 20 psi, and hopefully after a while we should see the atmospheric pressure, which is 14.6 psi. So it seems like that our conversion is working as expected. I think that the next step is obvious. We only want to update the left front voltage, temperature and pressure if the sensor is the left front sensor, because right now we are updating this all the time. For that we will create a new variable and let's call it left front updated. And that will store if this sensor was updated during getting the data. So in the beginning we will set it to 0, so it was not updated. And then after we find a device with the name BR, we will look for the address. And if the address is a known address, and we should have those addresses somewhere, so for the front left it's this address, so if it's this address and that's type of string, in that case we know that the left front sensor was updated. And then down here we can say that if the front left sensor was updated, in that case we will update all those values. And as the next step, we can do the very same thing for all the other sensors, being the left right, rear left and the rear right. Meaning that we need to create those variables 3 more times. And actually let's change this from left front to front left instead. That will make more sense. And replace all, because the next one will be front right. And then we will have a rear left and rear right values. Then we will look for all the known addresses. And then down here we will assign the variables based on which sensor was updated. not have so much data going into the serial terminal, I will comment out those serial print lines, including those in the loop function, including printing out the values of the manufacturer data, which is this case. And there is one more serial print function in here. And let's not forget to set all the sensors to 0, so front right and rear left and rear right. And we will print the new calculated values into the serial port only if those sensors or any of those sensors was updated. So if the front left sensor was updated, only then we will print those values in some understandable way. And let's do that for all these sensors. And with all those changes, let's try to upload it to the ESPIAO board. And now it's time for testing, so open the serial monitor. I will put the front left sensor inside the syringe and apply some pressure. And right now we are not printing anything until we get some data, so it will take a while. But at some point we should get some data, so let's remove the sensor from the syringe. And do the same thing with another one, this time being the front right, the FR sensor. And again we are getting some data, so let's continue with the next one. That will be the RL, the rear left. Again getting some data, and let's try also the last one, which is the RR, the rear right. And we also did get some data for this sensor. So it looks like that all the sensors are working as expected. We can get the voltage, the temperature and the pressure. So as the next step, let's not just only show those values inside the serial monitor, but also on the OLED display. And the nice thing about the Seeed XIAO board series is that you can get this expansion board, and once you solder those header pins to the Seeed XIAO board, you can just snap it inside, and you have access to stuff like buzzer or extra buttons or connection ports, but mainly the OLED display inside. This is the SSD1306 monochrome OLED display in the resolution of 128 by 64 pixels. This one has white pixels, and I have a lot of videos with this particular display type. By the way, as you can see on those screenshots, you can also get this display in the transparent version. I have recently used the very same Seeed XIAO board and the expansion board in this Dasai Moshi video, which means that there should be a link to the Walkway sketch. Now, Walkway is a free online Arduino and ESP32 emulator, and if I run it, you can see that it's playing some animation on the OLED display. So let's use that sketch as a starting point, but instead of showing all of those images, we will just show some labels. So I will first delete all those images, and that takes most of the sketch. And once I do this, we are left with only a few lines of code. We don't need this frame, and we don't need those 2 lines of code. So in the end, we are just starting the U8G2 library. That library is being used to draw on the OLED display, then clearing the buffer, drawing the image on the display which we don't need, and then sending the buffer to the display. So in between clearing the buffer and sending the buffer to the display, what we want to do is to draw some label. And for that, we can open the U8G2 documentation and look for some commands to draw text, for example draw string, and there is the example to set some font and draw the string being the hello world. So just copy and paste this inside our Walkway sketch, and then try to restart the simulation. And after a while, we should see the label hello world on the OLED display. So let's forget about those pressure sensors for a minute, and let's try to run this sketch on our Seeed XIAO board with the expansion board. So I'll just copy this sketch into the clipboard, jump into the Arduino IDE and keep this sketch opened, but create a new sketch, and then paste the code in here. And then if you have never used the U8G2 library, which is being used to draw stuff on the display, you have to go to Libraries and search for U8G2. And make sure to install that library. After that, we can just click the upload button to upload this sketch to our XIAO board. And once this is done, we should see the message hello world on the OLED display. Of course, we don't want to see just a static label, but all our measured data. So let's jump back into the walkway simulation. As a first step, we will try to use a simplest possible approach, and that is using a dedicated online application called Lopaka, which is meant for creating designs for embedded displays. So let's create a new project and call this TPMS. And we will be using the U8G2 library with the screen size of being 128 by 64 pixels. So click the submit button and we have a new screen where we can add rectangles, ellipses, strings and paint our own stuff. So let's start with the rectangle, which will be our car, and then select it and position it to the middle of the screen. And let's roughly draw something that looks like wheels, so maybe like this. And then copy paste it 4 more times. So 2 wheels on the front and then 2 wheels on the back. And then we can click the string tool and add our reading and make the text much bigger. For example, using this Pro Font 15 or maybe Pro Font 17 font, and change it to some value like 24.1. That will be the PSI value. And then copy and paste it. And this will be the temperature, for example, 24 degrees Celsius. And maybe for this one, I will make it slightly smaller, maybe using this font, the Helvetica font, and position it like so. And then we can copy paste it 3 more times for all the other wheels and 1 more time for the rear wheels. Okay, so we have a very rough, simple design, and for all of those elements, we have a code down here that we can use in our sketch. However, what we can do is we can prepare this even more by selecting the readout. And then next to the value there is this small button which is almost invisible, but if we click on this, it says add variable. We can look inside our code, and now we are not drawing the string that we are specifying in here, but it looks for the variable called the layer 6 text, which is taking the name from the layer name which is up here. So I think that what we can do is open the Arduino IDE sketch and copy the variable name, which is the front left pressure PSI, and use that name for the layer name. So instead of calling this layer 6, let's call this the front left pressure PSI. And then if we look inside our code, it's looking for the front left pressure PSI underscore text. Obviously later on we will delete this underscore text part, but this is a great start. So let me make this window slightly smaller so I can see both this design and the Arduino sketch with all those variable names. And let's use those variable names as the layer names inside the Lopaka application. So this next one is for the temperature, and we can continue like this with all the other 3 sensors. In the end, all our labels should be using variables, so let's just copy this code into the clipboard and paste that code inside our walkway simulation instead of everything that's inside the loop function. So this is the code from Lopaka, and we will also paste our variables from our Arduino sketch inside the walkway simulation. Now, as mentioned before, those variable names are not matching the variable names down here because there is this underscore text which we need to remove from all of those variables. And then we can try to restart the simulation, and while this is compiling, you can try to guess what will happen. And if you were guessing that there will be some problems, you are right. It's not being built because there is a problem, because the drawString function from the U8G2 library expects the text the C-style array, but instead we are feeding different variables. We are feeding the float variable and the integer variable, and the drawString function doesn't like that. And while we will later on convert those integer and float variables into the C-style string into the array of characters, right now we can test this using a different draw function from the U8G2 library. And that function is called the print function. The main difference between this print function and the drawString function is that there is no x and y position, so before drawing anything and printing anything with the print function, we need to set the position using the setCursor function. So just copy those 2 lines of code into the clipboard, and instead of calling the drawString function, we will set the position on the very same position as for the drawString function, and then print the variable using the print function. So let's do the very same change for all the variables. And then we can try to run it one more time. And after a while, we see our design on the OLED display with all zeros because we haven't set those variables to any values. And just for testing purposes, we can try to do that. So let me just enter some random values. and restart it one more time. And since this one also works, we can do a quick check on the real OLED display by copying the code into the clipboard, then pasting the code into the Arduino IDE and uploading it to the real XIAO board. Now at this point, we can easily combine our two sketches, one for getting the tire pressure sensor values and the other one for showing the values on the OLED display. But before doing that, I would like to make this slightly better looking, maybe having a nicer car in the middle, and also formatting those labels slightly, for example by only showing one decimal point for the PSI value because that's all that we got, we don't get the second decimal point, and maybe showing units for temperature values. But let's start with one thing at a time and redraw the car in the middle of the screen. Inside the Lupaka application, I will hide the car, actually the rectangle in the middle, as well as all those four wheels, and then select the paint tool and start painting the car one pixel at a time. And if we don't like that pixel, we can just right click and delete that pixel. So let me zoom in even a little bit more. Actually, I take it back. I think it might be easier to start with the rectangle, so draw a rectangle in the middle of the screen, and then set the size to maybe something like that. Make it center aligned for both the horizontal and the vertical center, and make it filled. And then we will click this merge to bitmap, so from this rectangle a bitmap will be created that we can now modify using the paint tool. So let me fast forward this a little bit. And while we are drawing, I think that we can also draw arrows that will point to individual wheels. So again, select the paint tool and zoom in a little bit and draw some kind of arrow. And we may need to reposition those labels slightly, like so. And then we can duplicate this arrow and flip it vertically. And then copy both of those and flip them horizontally. And of course, reposition all of those labels. If we want, we can even add the PSI label in here, because I don't think there will be enough space for the unit next to the PSI value, and as always we might need to reposition things slightly around, like so. And then let me see how this will look like with the units being displayed for the temperature, so degrees Celsius for all of those four readings. And I think that this looks very nice, so let's just use that for the final design. So let's just copy the code and paste that into the walkway sketch, and for now let's just comment out everything that we have currently in there, not quite sure if we will need it or not. And I might move those definitions for those images outside of the main loop. But we still have the problem that we were facing previously, and that is that the temperature is type of integer and the PSI is type of float, and none of that is possible to be drawn using the drawString function. Which means that it's finally time to convert integer and floats into the C-style arrays into the C-style strings. Because we need to draw the C-style string, the array of characters, we will create a new variable that will be type of the character and that will be the array. And let's just call this helper C-string with maybe up to 10 different characters, and that will be our helper variable that will store the string before drawing. So before drawing the temperature, we want to convert it into this helper C-string, and for that we will use the sprintf function, and we first say into which string we want to convert everything. Then we will provide a string of text or references to variables, and if we want to reference the integer variable, it will be $d. And then in the last step we will list all those variables, and we only have one, which is this front left temperature. And then inside this drawString function, we will draw this helper C-string instead. And just because the other parts are not fixed yet, I will comment them out so I can test the temperature value and then restart the simulation. And since this works, we see the temperature. I would like to also show those units being the degrees Celsius, and we can try to just type in degrees Celsius into this string and run it again. And we see the letter C, but we don't see the degree symbol. And if we look at our used font, the U8G2 font Helvetica B08TR, the letters TR are quite important. Because if we open that particular font, usually fonts come in few different versions to save the memory as much as possible, starting with this TN, which stands for numbers, so we only have numbers. Then there is the TR, which is reduced, and it only has the characters and the numbers, and that's the one that we are using currently. And then we have the F version, the TF version, which stands for full font. And here you can see that we have the degree symbol, but we don't have it in the reduced version. And sometimes the font will even have the E version, the extended version, but I don't think that we need that version. But we definitely need to switch from the reduced version from the TR to the TF version. So let's change the font from TR to TF and run it one more time. And now we see the degree character, but we also see the letter A, which is nowhere to be found inside our string. And I think what's happening is because this degree symbol is just part of the upper ASCII character, it's having trouble being drawn using this drawString function. So I think that we can use a different function for drawing the label. Instead of using the drawString, we can use the drawUTF-8 function. So let's just try to use the drawUTF-8 instead and see what happens. And that change seems to fix it. There is also a second way how to do that using the drawString function, which I have found. And that is not typing the degree symbol inside the string, but instead use the %C, which is for referencing the character, and then inside the list of variables, we will set the value to the ASCII character, which is the 176 in decimal. You can see it in the actual font if I zoom in a little bit. This is the degree symbol, which is the 176 in decimal. This will, by the way, this will be 177, 178, 179, and so on. This will be 192, 93, 94, and so on. So if we do it like this and restart it one more time, we do see the degree symbol without any extra characters, without the need to use the drawUTF-8 function. So let's apply the very same principle for all the other temperatures. And of course for now, keep the PSI drawing commented out. And since the temperature is showing correctly, we can move on to the next step, which is showing PSI values, which again is the type of float, and we want to convert it to the C-style string. And for that, we will use the D2strf function. And here is a nice overview of that function. So let's just copy this into the walkways simulation. First we set the bigger font and then we call this function. The floating value is this PSI value. There is no requirement for the minimum bit and we only want to show one digit after the decimal point. And I think that we can use the very same helper C string to also store this value, because all that we need to do is to just draw this helper C string to the display and then we can use it for something else. So all that I need to do is to apply the very same function, the D2strf function, for every PSI readout, and then draw the helper C string using the drawString function. And then of course restart the simulation one more time. Now I'm still setting those pressures to very small values because previously we were showing 2 decimal points and it wasn't possible to fit bigger numbers, but I think that now with only 1 decimal point we should be able to fit the numbers up to 99.9 psi. There is still one very last change that I would like to make, and that is to align those labels on the right side with the right side of the OLED display with the right side of the screen. Basically making those labels right aligned, but there is no option to right align the label inside the U8G2 library. So what we actually need to do is to measure the size of the label, measure the width of the label, and then adjust the DX position accordingly. And we can measure the size of the label by calling the getStringWidth function. So we'll just use that function to get the width of our strings. And let's maybe create first a new variable and call it helper stringWidth. And then whenever we are drawing strings on the right side of the screen, which we can tell from the X position, so X0 means it's on the left side, but 89 it's definitely on the right side, we will use that getStringWidth function to get the width of our helper C string and assign it to the helper C string variable. And then when we draw the string, we will set the X position to the width of the screen, which is 128 pixels, minus the width of the actual string. And again do that for all the strings which are on the right side of the screen. And with this final design, it's time to merge this OLED drawing sketch with our pressure sensor sketch. So let me make this smaller so we can include bits and pieces. As a first step, we need to include the U8G2 library and then initialize the display with this line. And then scroll down to the setup function, and inside the setup function we need to call the U8G2 begin function. Then copy all our images anywhere in the code. And then inside our main loop we are printing everything into the serial port. We can probably keep that. And then there will be the OLED drawing. And for that we will copy everything from our main loop and paste it in there. And we are waiting 2 seconds. I don't think that we need to do that. We can probably lower it to maybe like 50 or not have it there at all. And then let's do one last upload for today. And then as I'm applying the pressure to those individual sensors and waiting for the display to update, let me tell you a few things. I did get 4 of those sensors, but you can get any number, I believe from 2 all the way up to 6, 2 being of course for the motorcycle, 5 being for the car with the spare tire, and 6 for being something like the RV. I've seen some photos on the AliExpress showing those sensors on the semi-truck, but I don't think that you can use them for that because those sensors will only report values up to 100 psi, and for semi-trucks those pressure values might be higher. In the beginning of the video, I have briefly mentioned sensors using radio waves, and there is a great video from Andreas Spies about how to use those sensors. I will make sure to put the link down in the description. Finally, if you know any iPhone application that works with those sensors, please let me know in the comment section. That's everything for today. Thank you very much for watching, and I hope to see you soon. Thanks and bye.